All right, well, here's some your sample problems from your packet, page 11. And we're just going to dive right in, trying to connect with our pre-lesson. So here we go. We got 6r is perfectly balanced with negative 12 plus 3r. Just to get started on this stuff, I'm just going to kind of mentally think, okay, I'm going to identify where my like terms are, and I'm going to get the boxes on the left-hand side. So I'm going to go ahead and subtract 3r from this side and subtract 3r from that side. There's my infamous Kerchunk bar. And I'm going to get 3r is perfectly balanced with negative 12. And now I'm going to divide by 3, divide by 3. I'm going to get r is negative 4. One thing I didn't say, and I should have during the pre-lesson, but I'll say it now. You can always plug these back in and double check your work. So what's 6 times negative 4? Negative 24 is perfectly balanced with negative 12 plus, now notice, negative 4 times 3 is a negative 12. And just look at it. That has to be true. Now, I'm not going to plug them in every single time for the remainder of this assignment. But when you're struggling with one, you can definitely do that. That's the benefit of solving equations. But let's go ahead and go to this guy. So as you can see, I've got these terms that are constants. Then I've got this term that has a variable. So I'm going to concentrate on moving that 18 over. For chunk bar, those cancel and end up with negative 2/3 f is perfectly balanced with negative 6. Now I've got a fraction here. Now I'm going to look at the end result. I want 1f equals some number. And if I can get to here, then I know that f has to be equal to that number. Well, somehow I got to make this negative 2/3 equal a 1. Well, the only way I can do that is by multiplying by the reciprocal. Negative 3 over 2, negative 3 over 2. Notice what happened. What's anything times its reciprocal? It's 1. So I get 1f is perfectly balanced with, now let's look at this, a negative times a negative is positive, and so these will cancel. Now I'm going to go ahead and cross reduce. 2 goes into 2 once, 2 goes into 6 3 times, 3 times 3 is 9. And there's my answer, f equals 9. Most of you would probably write it like that. Let's go on to this next one. Got a little bit of work to do to get started. Let's go ahead and multiply. So I'd get 6t minus 8 is perfectly balanced with 6t plus 3. Now, if you're just using your head and looking at it, this just can't happen. How can I subtract 8 from something and then add 3 to that same thing and get perfect balance? It's impossible. So I already know this is no solution, but let's go ahead and act like I didn't know that. Let's add 8 to both sides. And let's subtract 6t from both sides at the same time. There's the big old Kerchunk bar. And then these would cancel, these would cancel. I end up with 0 is perfectly balanced with 11. Look at what happened. My variable disappeared and I end up with a false sentence. You know what that means? This is no solution. If you want to save some time, you can just kind of go like that. That little symbol right there is what you have for empty set and null set, okay? All right, diving into this. A little bit more work here. Going to distribute a fraction. That makes your life a little bit miserable. 3/5 a minus 3/5 equals a plus 3. All right, now in the pre-lesson, I said, hey, you can multiply any equation you want at any time if it benefits you. And I'm going to take advantage of that rule, and I'm going to go ahead and multiply this whole thing by 5. Why 5? Because they're going to cancel with these denominators, and it's going to clean things up big time. Again, a benefit of dealing with an equation. So I'm going to multiply, 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 multiply. Now I'm going to show my work. 3/5 a, And then plus, I'm going to go ahead and put a plus there, 5 over 1 times negative 3/5. That negative comes from that minus. In other words, I just kind of thought of it like that. And then equals 5 times a plus 5 times 3. Notice I've multiplied everything by 5. Now notice what happens. These cancel, and I'm left with 3a. These cancel, and I got minus 3 equals 5a plus 15. So, a little bit of a pain, but notice the benefit. No more fractions. So now, I'm going to subtract 5a from this side, which means I have to subtract 5a from that side. I'm going to add 3 to this side, and I'm going to add 3 to this side. Notice these cancel. I end up with negative 2a is perfectly balanced with, these cancel, 18. Divide by negative 2, divide by negative 2. I get a is negative 9. And again, if you're worried about it, you can plug it back in. All right, let's tackle this one. I'm going to go ahead and go like this so we can stay a little organized. Distribute, distribute. 1.5x plus 1.5 times 2 is 3 equals 7.5. Now, I could multiply this by 10 right now just to get rid of the decimals. But I'm going to go ahead and just deal with it. I'm going to subtract 3, and I get 1.5x equals 4.5. I'm going to divide by 1.5. I'm going to divide by 1.5, and I get x is, notice these cancel. That's where the x comes from. And look at that, 4.5 divided by 1.5. You can check it with your calculator, but that equals 3. So that just kind of worked out. Sometimes they work out, sometimes they don't. Next problem. Distribute, distribute. 10x minus 6 minus x equals 9x minus 6. And I'm going to clean this side up right here. Notice I've got a 10x and a negative x. That's 9x minus 6 equals 9x minus 6. Now, do you notice something? This is one of those that's a little unique. This is going to be all solutions or all real numbers. But let's say I didn't notice that, and I added 6 to both sides, and I subtracted 9x from both sides. This would cancel, leave me with a 0. This would cancel, leave me with a 0. You know what that means? All real numbers. In other words, everything works. You can be fancy with that by making a little fancy R, all real numbers. Okay, so you kind of get the idea. I've got 8 minutes into this video. These here are very similar to these. So I'm going to go ahead and skip these just for time because these videos need to be less than 15 minutes. So this one's a little bit of a stinker, a little different, so I'm going to tackle it. Well, this right here is actually, if you want to think of it, that minus sign is an add op, which is telling me take that negative 2 and distribute. Now I'm going to show my work, 6x minus 2x plus 8. And I'm going to go ahead and clean that up, which is 4x plus 8 over 3 equals 8. Now, in a previous lesson, I said it's okay to take this into that and this into that, but you notice 3 doesn't go into 8 and 3 doesn't go into 4, so I'm going to take advantage of my other rule. I'm going to multiply this side by 3, but I got to multiply this side by 3. Notice what happens? These cancel. I end up with 4x plus 8 equals 24, which is perfectly balanced with. Subtract 8, subtract 8. I get 4x is 16. Divide by 4, and I get x is 4. There's example 9. Okay, now on the back side of that, moving to page 12, we've got a couple more sample problems. And this is just unique. This looks a lot harder than it is. But this says, if I just said, it says, tell which number to the right of the equation is the solution of the equation. Well, this is saying basically let x equal 0 and just plug it into this thing and see if it's true or false. So I go 0 plus 6 all over 2 times 0 minus 3 equals 0 minus 2. So I got to clean that up. Well, 2 times 0 is just 0. It's gone. The 0 here doesn't matter. This is saying, what's 6 divided by 3? Well, that's negative 2. Is that perfectly balanced with this side? Yes, it is. So that means this is a solution. This is a yes. It works. Now I've got to take the negative 1, plug that into this thing, see what happens. Negative 1 plus 6, 2 times negative 1 minus 3 equals negative 1 minus 2. I just got to clean this little mess up. What's negative 1 plus 6? 5. What's 2 times negative 1? Negative 2. What's negative 2 minus 3? Negative 5. Equals, look at this, negative 1 minus 2 is negative 3. Well, what's 5 over negative 5? That's negative 1. Is that perfectly balanced, or does that equal negative 3? Question mark, question mark? No. So that's it for that one. All right, last two sample problems before you tackle your homework. This is a little bit different. This is saying solve for x, but you notice over here there's no numbers. So you just have to kind of work ahead and say, all right, what does solve for x mean? It means get x alone. So I'm going to start by subtracting b, subtract b. These are not like terms, so I have to write y minus b equals mx. Well, how do I get x alone? Because it's not alone yet. Divide by m, divide by m. I get x equals this wonky looking thing that has no numbers, just darn letters. But that's my answer. And if you're curious, you could write it y over m minus b over m also, but this is going to be the desired answer in your where you access your answers for your homework, okay? Last one, solve for L. Well, where is it? It's right there. In other words, get it alone. I'm going to start by subtracting 2w. Subtract 2w. There's my Kerchunk bar. Boink, boink. Over here, I don't have any like terms, so I'm going p minus 2w equals 2l. Now, I made my L cursive, so I don't mistake that for a 1. It's not alone yet, so I'm going to divide by 2, but I'm going to divide all this by 2. Over here I get L equals, and this thing does not clean up, P minus 2W all over 2. And there it is. All right, tackle that homework assignment, you guys. These homework assignments are very, very, very similar to these practice problems. So dive in, and good luck.